Shall we start?
Yes, sir, we'll start.
Okay. So let me share my screen. So are you able to see my screen?
Yes, sir.
Okay. So we talked about hashing yesterday, right? I have a couple of concepts I want to mention and examples I want to demonstrate. So you can use command line within your Windows desktop to get the hash content of a file. So if you go to Start and you type in PowerShell, you'll be able to launch the PowerShell window. The command is, let me go to my desktop. Command is get file hash. Okay. So I have a file here. So get file hash in whatever file will give you the hash of a file. So this number again, I mean, this string is unique. So if I were to send my photo to someone else and they were to run the same command, they will get the same hash string. Is that understood? Okay. Another important application of hashing is that your operating systems typically store your password in the form of a hash. So for example, I have a Linux machine here. So I'm running it as a virtual machine. And do you know where the password file is located in a Linux operating system? Anyone? Okay. So the command to get it is okay. So /etc/shadow. Shadow is the file that typically has the list of all your users. And when you create a user within the Linux operating system, the hash is also stored there. So if you see at the bottom of my screen, I have a user called VJ. So next to it is the hash. So it makes a couple of different calculations. $6 means it's in shared 256. So we learned that it was one of the hashing algorithms yesterday. It adds what's called a salt. I'll talk about it. And the remaining is a hash, and then it has other parameters as well. So this is the same of Windows as well, but it's kind of difficult to get the hash out of a Windows system very easily, unlike Linux. So what is salting? So salting is a mechanism by which you add some random characters to your plain text password and hash the entire thing. The reason is the same I stated before. For the same password, if two people use the same password, it is possible, like when you have a website, there are hundreds of users registering on your website, they might have the same password. So what that will translate is, if you use the same hashing algorithm, they will also have the same hash, right? Now we don't want an attacker to be able to get a copy of a database and look at it and see, 3 or 4 users are having the same hash, and he's able to kind of figure out a pattern out of it. So you add what is called a salt, like salt, right? So you add some random characters to your password, and then you hash the entire thing. So that makes pattern deciphering very difficult. Any questions? Okay. So we were looking at redundancy concepts yesterday, right? Anybody has any questions about what's a hot site, warm site, cold site? So these are recovery scenarios for your entire building or entire data center or entire locations. So let's go inside. So your data centers, houses, servers, network equipment, firewalls, several other computing infrastructures. So how do you build redundancy within them? I'm just showing you an example of how a website will be typically located. You will have your internet-based firewall. You will have what's called a load balancer in the front end. We'll talk about it. And you typically, when you have a large user base, right, you cannot run your website on a single server. You have to be able to spread your code across, or your website across multiple servers. For a big website like Facebook or Instagram, you can't really run the same, or run the website on one server. So the act of distributing your website across multiple nodes is kind of a redundancy technique. So that's kind of a load balancing technique. Okay. So at the back end, you might have what's a firewall, because websites are facing the internet. You want to have firewalls on both ends, and websites will usually connect on the back end to a database. You have a list of users. You will have their profile information. If in case of financial transactions, you'll have that information. If you're working for a company, you might have employee information, all their related salary and all those things, departments, position, all. So all these will be in the database. So there has to be database redundancy built in as well, because if one database fails, you should be able to recover the information from the redundant database or the secondary database. Okay. So at the very end of bottom of everything, all servers have hard disks on them, right? So you have to build disk-based redundancy as well. So even if one hard drive fails, the entire server should not go down. Typically in a laptop, how many hard drives you have, or in your PCs, just one, right? For server operating systems, that's not the case. You must have multiple hard drives, and they must be fault tolerant. Understood?
Yes, sir.
Okay. So I'm just talking about what are the load balancing techniques for different aspects. You need not go deep into it at this moment, but just know. I told your web server has a load balancer in the front end. So when traffic comes from the internet, when people are accessing your website, a load balancer is a component that decides where the traffic gets routed. So which of your web servers will handle that traffic? Okay. So there are several vendors that offer load balancers. F5 is one popular vendor. Some of the load balancing techniques involve, I listed here. So first one is round robin. Round robin is your typical common sense type of thing. First connection goes to the first server, second connection goes to the second server, third connection goes to the third server. Okay. So the next advanced level is what's called a weighted round robin. Weighted round robin is when you might like to assign certain weights to different nodes, right? So if this type of request comes, if a request comes to make a payment from a website, it has to go to this web server. So if a request comes to this, for this purpose, for just registration, it goes to this web server. So you might want to route traffic based on certain characteristics. Okay. The next technique is least connection. So this is a type where you might ask the load balancer to send the next connection to the server that's handling the least number of connections. So whichever server is having the most smaller number of connections, that's where the next traffic should go. The other type is resource-based adaptive connection. So you might want to tell the load balancer, okay, look at my web servers. My web servers are using CPU, memory, hard disk, all those computing resources. So look at which server is using the least amount of resources and send the next connection to that resource. Okay, there are several others, but this is to just give an idea of how a load balancer would typically work. Got it? Okay. So the next aspect, so you have your web servers, right? So what I told before is you got to make sure you have to distribute your code, your website across all the web servers. So the challenge here is to make sure all your servers run the same code, because while it seems easy, practically it's really difficult to ensure all the servers look the same. When in nature, there is nothing of the same concept, right? But we have to do our best to ensure all your nodes run the same code, all your nodes have the same configuration, have the same operating system, same build, same patch. So this becomes a challenge when you add multiple layers and multiple requirements into making sure all your websites going to have, they want to look the same. If they do not look the same way or do not act the same way, one user might get one experience, another user might get another experience when they access your website. So you don't want that. Some users might have an error, right? So there are several tools that can do this for you. They are called configuration management tools. So configuration management is a general term. You'll be using this widely in IT industry. It's when you try to maintain the consistency of your system configuration. So make sure everything is according to standard. Every system looks the same. Every system works the same way. Okay. Some of the vendors that offer these tools are Chef, Puppet, Ansible, SaltStack. So you can go to YouTube and find out more about how they work. So these tools make sure your code gets easily deployed. They are automated. Now, once you deploy one piece of code, the software makes sure it's distributed across all your nodes. Any questions? Okay. So let's talk about databases, right? So there are database replications techniques as well. So when you'll have multiple database servers at the backend, one will usually be a primary database. Your secondary database will usually be located in a DR site. So you want to make sure all the updates that take place on the primary database get replicated to the secondary database. So in case there's a disaster in the primary site, you will still have your database in the backend, in the disaster recovery site. So you can recover all the content, all the tables, databases from your backup secondary database. So there are few vendors that offer databases. You have SQL, Oracle, MongoDB, MySQL, NoSQL. There are several databases, database products. I'm just showing examples of SQL replication types. So the first example is called a snapshot replication. So snapshot replication is a method in which you take a picture of a database, essentially. Snapshot is, again, a widely used concept. You have snapshot of virtual machines, snapshot of operating systems, and all those things. So snapshot is a picture in time, a point in time snap of a component. So in this case, it's our database. So it distributes the component as it is in a given point of time and sends it to the secondary database. Okay. With databases, the challenge is to make sure that your snapshot is consistent in a sense where the data you have in any given point of time is not like a intermittent data, right? You're in the middle of a transaction, you're making updates to a database regarding a financial transaction. You don't want to snap a database when it's in its inconsistent state. Okay, you got to make sure either the transaction takes place, okay, or you got to make sure that the transaction is held back until you complete the snapshot. So whenever you ship snapshots, your database must be in a consistent position, or it must have that integrity inside it. So all the data should be consistent. So So that being the challenge, this type of replication can be done only on databases that have very little activity. You can replicate only small volumes of data, and even if there's a large volume of changes, it still has to occur over a short period of time. Okay. The next type of replication is called log shipping. So any update you make on your database, it will create what's called a transaction log. So any create, you add an entry, it creates a create log. You delete something, it creates a delete log. So if you can replay those logs in the reverse order, you can essentially create a copy of the database. Okay. So it makes sense to have log shipping as a method of replication. So you don't have to take a copy of the entire database and ship it over. You can have a copy of all the transaction logs, and you ship those logs to the secondary database. The logs will be replayed by the secondary database, and you'll have an exact copy of all your records. Okay. Any questions? Okay. So the third concept is called merge replication. Merge replication is where you have data that's changing both on the primary and the secondary database at the same time. Users are updating both databases. I know at a given point in time, or when this one database is able to communicate with the other database, the changes are merged. So they talk to each other and they make sure both of them look the same way. Okay, you can read about this more on the Microsoft website. So I'm just letting you know what the general concept of database redundancy is. Any questions so far? Okay. So the last aspect of redundancy, we'll talk about RAID. So RAID, as I mentioned before, is a method where you can ensure fault tolerance of your hard drives. So I'm just going to talk about this a little bit in more detail because this might be an interview question. I was asked this question. So we'll talk about how redundancy can be built into hard drives. So RAID is an acronym for Redundant Array of Independent Disks. So what I have here is a picture of what a server will look like, server hardware will look like. So unlike your desktop PCs where you have a screen, your keyboard, mouse, server will just look like a box here. You'll mount this on what's called a rack. Okay. So in front you see these modules with green lights, right? So those are your hard drives. Okay. So if it's all green, then it means it's functioning well. If it's not, it'll show a red light. You might have to swap your drives. So when you swap drives, there will be what's called a rebuilding time. We'll talk about it in how RAID is set up and all those things. Okay. So the first type of RAID is what's called a RAID 0. So the RAID 0 is, in other words, it's called striping. So when the operating system writes data on a RAID 0 configuration, the first block will be written on the first disk. The second block will be written on the second disk. So it will alternate blocks. Okay. So the advantage of a RAID 0 configuration is it has high read and write speed because it's able to read data from both hard drives. Okay. And the second advantage is all the hard drives can be used. I mean, in the sense that your data is occupied by all the hard drives. We'll see why that's not the case with the other RAID configurations. But remember, with RAID 0, all your hard disk space is effectively utilized. Okay. So disadvantage of this configuration is there is no recovery. Okay, when you set up two or more hard drives in the RAID 0 configuration, when one drive fails, you won't be able to recover the data that's from the failed hard drive. Got it? Okay.
Yes.
The next type of RAID is called RAID 1. It's called mirroring. So with mirroring, when your operating system writes data on one hard drive, it also makes a copy of that block on the other hard drives that are part of the mirroring setup. So your one disk will always be a primary disk where data is written. All the other disks set up in a RAID configuration, in a RAID 1 configuration, will have copies of the data. So the advantage is, it has high read speed because the operating system can read data off of multiple hard drives at the same time because they are essentially copies, but there won't be much of a write speed gain. That's because when the operating system writes data on one hard drive, it has to make sure it's also writing a copy of the block on all the hard drives. Okay. So the advantage of RAID 1 over RAID 0 is it can tolerate drive failures, right? So when one drive fails, you'll still have data on the other drive because the copy is available immediately. And when you swap a drive, you put a new drive in, the operating system will be able to just copy the data off from the primary drive onto the new drive that's inserted. So that's your building time. Okay, so whenever you insert a new drive, there will be a software that recognizes that you inserted a drive, and it will rebuild the RAID. Okay, so the data can be essentially copied off the hard drive that's working in a mirroring type setup. So the disadvantage of this is your storage capacity is reduced by half, essentially, or more, because you see only one, when you write data on one block, it's copied over all the other blocks. All blocks essentially are copies, right? So there are mirrors. So if you put 4 hard drives in it, you'll just have one primary copy. All the other drives will be used for mirrors. So you just have the storage capacity of one drive, even though you have 4 hard drives in your system. Got this concept?
Yes, sir.
Okay. So next one is RAID 5. So RAID 5 is striping with parity. So for your RAID 5, you need 3 drives. For RAID 0 and RAID 1, you will need just 2 drives at a minimum. You can have multiple drives. At a minimum, you need 2 drives. For RAID 5, at a minimum, you need 3 drives. So as your data is written across blocks, okay, across drives, there will be one drive that's reserved for parity. Parity information can be used to rebuild information on all the other blocks. Okay, so if this is a parity byte and parity block, and if you lose this disk, okay, if you lose the 3rd hard drive, this information can be used to rebuild the failed drive. Okay, so you'll see how the parity bit is spread across multiple hard drives. So this is the most commonly used RAID. When you consider cost versus functionality, you can tolerate one drive failure because there is one parity bit that's written up, one parity block. So that's on one hard drive. So it can tolerate one drive failure. Okay. So advantage again is read speed because you're striping your data across multiple hard drives. The write speed is slow, which is disadvantage because when it's distributing the data, when it's writing data across different hard drives, it has to calculate this parity bit on the last hard drive. Okay. And again, when you talk about rebuilding, RAID 5 is slower than RAID 1 because this one with the RAID mirroring is just a copy, right? Here it has to recalculate the parity based on all the other hard drives, and it has to do the rebuild. Got it? Okay. So the next one is RAID 6. So RAID 6 is again an advancement over RAID 5. It's striping with double parity. So the stripes are written across hard drives, but 2 drives are used for the parity bit. Okay. So again, an advancement, it can tolerate 2 drive failures. While the read speed is fast, the write speed is slower than RAID 5 because it has to calculate parity to be written on 2 drives. Okay. And rebuilding again even takes more time. It has to calculate parity bits of 2 drives. Do you understand this concept?
Yes, sir.
Okay. So with RAID 5, I told you you needed minimum of 3 drives, right? What do you think is the minimum number of hard drives needed for RAID 6? Anybody? 4. Okay. So you need at least 2 blocks for striping data, and you need minimum of 2 blocks for parity. Okay. Okay, the last RAID I want to talk about is RAID 10 or RAID 1 plus RAID 0. So this is like gives you high performance as well as some kind of redundancy. Okay. So RAID 1 plus RAID 0 is a combination of both striping and mirroring. Okay. So you have, when you write a block, okay, it's striped and it's mirrored across one drive. So you see block 1 and you have a mirror here. And block 2 is written across on the other side and you have a mirror of block 2. Okay. So this is easy to understand picture-wise more than me explaining it. So you can see that it's striped across drives and it's also one copy of a mirror is also available. So the advantage here is, rebuilding time is quick because it's, with mirroring concept, always rebuild is really quick. With parity, the rebuild time is a lot slower. The disadvantage is half the capacity again goes for mirroring your hard disk. So let's just make a calculation of how different RAIDs affect our storage capacity. Okay, you ready? Okay, with RAID 0, I have 4 500 GB hard disks. Okay, I got to insert them into these servers, and the software sets it up. How much storage capacity do you think I will get when I set it up as a RAID 0 configuration? Any guesses? So I told you with the RAID 0, all the storage capacity is in use. So you will get, is this concept clear? You get the entire storage capacity multiplied by 4. Anybody, any questions? Concept not clear? Okay. So with RAID 1, tell me. So I told you there will be 1 copy of the primary data that's written on the hard drive and multiple copies of the mirrors. So how much capacity do you think you'll get?
Half of the previous, sir. Half of 2000 GB.
So 1 is your primary copy. The rest are mirrors or copies of the primary. You're close, but not exactly accurate.
Okay, sir.
But you'll get 500 gigs. Because only 1 hard disk is used for your primary data. The rest are mirrors. They're copies. Okay. with RAID 5. Three hard disks will be used for writing your data. One disk will be used for parity. You have 4 hard drives of each 500 GB capacity. How much will you get with RAID 5? Anybody? You get 1,500. I mean, it'll be less, a little bit less than this because of all the overhead. But in general, you must get close to this because 3 drives are used for writing your blocks. 1 drive will be used for parity. Is this concept clear?
Yes, sir.
Okay. RAID 6, anybody? Two blocks written across 2 drives. 2 blocks for use for parity. 2 drives will be used for parity.
1000 GB, sir.
Correct. I'm really happy that someone understood the concept. RAID 1 plus 0. Again, it's going to be 1000 GB. Okay. So striping will allow you to use 2 hard drives. Okay. And the mirroring will be used for 2 others. So 2 hard drives will be in use over here. So you'll get 1000 GB capacity.
Okay, sir.
Okay. If you go for a system engineer position interview, I'm sure you'll be asked this question. Okay. So what is RAID and what are the different types of RAID? Okay. So let's talk about backups. So I was a backup engineer during my work. I handled more than 10 petabytes of data. We got to ensure the backups are consistent, make sure it's every day we have a copy of all the backups. So when I talk about redundancy, okay, I talk about immediate recovery. You know, when a failure happens, there is a an immediate recovery plan. Okay, so one thing fails, another thing immediately picks that up. Okay, so with backup, you don't expect it to pick things up immediately. You have a copy of your data that is stored at an offsite location. Okay, so this is a requirement for many regulations. So you must have a copy of your data stored in different or a remote location where you can bring it back and recover your main system, or even sometimes it's used to see how your data looked a few days ago. Say, for example, your database becomes corrupted, right? What happens in a redundancy scenario? Your primary database becomes corrupted for some reason. The same corruption will get replicated to your secondary database. So you don't have a lot of control over it before, to stop it before it happens. If you set up, frequent log shipping, set up a database to replicate, look like mirrors of each other, then if one point gets corrupted, another point gets corrupted as well. So the same goes for a web servers. Some file gets corrupted, all the web servers will take away that same file. If you push out the wrong code, for example, if you use Puppet or any other tools, they will just push out the configuration. And if your website goes down, where will you recover your correct file from? So that is the reason why you need backups. Okay, you need a copy of your config files. You need a copy of your correct or original database somewhere. Okay. So a couple of types. You have a primary primary data center. You have backup tools, like you have IBM, you have Commvault is a vendor. So you'll install a backup software on your OS. Okay, the backup software will take care of safely shipping your data and shipping your data in a consistent way. I told you about the challenges with database backups and all, right? So backup software can handle all of those things. So you have a primary data center. One method of doing the backup is doing a backup on the WAN link. So WAN link is wide area network on the internet, or a configured company wireless LAN. I'm sorry, the wide area LAN. So you can set up the software to send a copy of your data over the WAN to a remote site, which is housing a server and a storage area. Okay. That is one method. The second method, this was the one that was used previously when internet facilities were not very developed. You had what's called tapes. So you remember cassette tapes? I don't know if your generation is used to seeing something. So the tapes are used to take magnetic copies of your data. So you have a HP tape system. You can insert your tape here. Your backup software will then write a copy of all your data onto the tape. Okay, then you take the tape out of the LTO tape library and you put them in a truck and you ship it to a offsite storage. Okay. So what are the conveniences and disadvantages of both things? So with a WAN-based backup, obviously it is quicker and you're storing it on essentially a server, okay, that has a storage or hard disk attached to it. So this is easy to recover, right? So when you want to recover data, you can just have a software rerun or restore, and it will take all the data from the remote location server and it will recover all your data. The problem is this is kind of an expensive solution because you have to make sure, you cannot just place a server in some building, right? You have to have a rack, you have to have a cooling system, you have to have the proper setup, network switches, and you have to make sure that the room is always online, the server is always online. Again, you have to build redundancies even for the backup server, right? You have to set up all this RAID and all those things. So it is an expensive solution. You got to make sure your data is always online. Your backup data is always online for you to be able to recover quickly. So the tapes are very inexpensive solution, okay? And it also has a benefit of not, you don't have to spend a lot to maintain tapes. You can store it offline like your pen drive, right? Do you have your pen drives? You can throw it anywhere and put it in and it will work. So similarly, tapes will have data archive. You can store it if you store it in a proper way, you can store tapes for years, okay, without any issues. The only problem with tapes is recovery. Recovery can be quite slow because depending on how big of a tape library you have and how big of an LTO loader you call it. So you can insert multiple tapes in some instances. If you have really old tapes, you need that specific tape drive in order to make the tape work if you have it functioning in your organization. So all these challenges come. When you store tapes for a long time, you got to make sure you have the equipment to recover tapes, okay? You don't throw away those things and tapes will be just lying there. You can't recover any data from it. It's not a matter of doing your backups. It's a matter of recovering them. Okay, you have to be able to recover your data. You have to frequently test whether you're able to recover data from your backups. So even when you're developing a website, you're hosting a critical system, always ask the person who the system engineers, network engineers who are responsible for maintaining the underlying operating system, that whether they have all your data backed up. But if you make a mistake and your web server goes down, redundancy won't help. You got to recover your data from backups. Okay, so backups are not done in real time. They're not mirroring and all those things. They are done, once a day. If it's really critical, like once every 4 hours. No, they are not very frequent, like your, DR setup. Any questions? Okay, so the last concept in availability, it's called patch management. Patch management, I would say it's an art. It's more than it's not a science. It's an art of deploying software updates, because if no organization I've seen manages to do this correctly, even the big ones, okay? So I think if you want a Windows system, you might see once a month, it will run a software update and it will try to restart automatically, right? In the security realm, a software update is usually we don't worry too much about non-critical ones, like your software that updates the code on your OS makes performance-wise better. We're worried about the updates that fix security flaws. So what is the official term for security flaws? Vulnerabilities. Okay. So we are always on the lookout for new vulnerabilities and new patches that fix those vulnerabilities. Okay. So who issues patches? Patches are usually issued by vendors like Microsoft, who own Windows, Linux, Red Hat. So VMware is another vendor who supports virtualization. So they issue patches for their hosts and their virtual machine software. You have application vendors like Adobe, Apache, Drupal. You have your browser vendors like Firefox. If you use a browser, you might see your operating system is up to date. You have equipment vendors like even your mobile vendors like Apple, uh, and you have Google or whatever mobile device you own. They also run updates frequently. These may include security updates as well as performance improvements or new features. You have network equipment vendors like Cisco, Pulse VPN, so VPN vendors. Sonic is a firewall vendor. Cisco runs multiple security solutions. So they have a cadence with which they issue patches. The usual date in the month is the second Tuesday. So I think it was yesterday. It's called Patch Tuesday. Major software operating system vendors release their patches on this day. So we as security professionals are always on the lookout for Patch Tuesday. When a patch comes out, we make sure we take those patches, we assess the risk of each patch, and we will try to make sure our companies are updating their system with the latest issued patches. Okay. So there is a lifecycle. Patch management is an ongoing process. It's very difficult, and it's a big headache if you're not aware of what kind of operating systems you run in your environment, what kind of network equipment you run in your environment. As your company goes big and large, you will have a lot of IT equipment, right? Right from your cameras to your access point, Wi-Fi routers, to your desktop applications, your desktop itself, your Windows operating systems, your PowerPoint software. You have your servers, web applications, frameworks. You have your packages, libraries, modules that you import for building your websites. Then on the back end, you have all your databases, your SQL software that needs to be kept up to date. So a lot of things. So companies, they make sure they log all these applications. They make an inventory of everything they have. So that's again a big position in a company, right? It's a paid position. You call it asset management engineer. You'll have an asset management lead whose sole responsibility is to make sure all the applications, your network equipment, operating systems are all cataloged. Okay, so that's even a requirement by some regulations, because you have to make sure your organization is up to date with security updates. Otherwise, you are going to have a weakness which a hacker can exploit. Got it? So when I talked about all these applications and vendors, right? You have vulnerabilities, weaknesses in every application. New vulnerabilities are discovered by researchers. All of this is cataloged in what's called the National Vulnerability Database. It's run by NIST, a part of the US government. So they kind of try to catalog all the vulnerabilities. So every vulnerability that's released gets a CVE ID. So that's a unique number that's used to track every vulnerability. And if you look at it, it'll have a description of what it is. A remote code execution exists in Microsoft Word. Okay. So what is the risk with that vulnerability? It's tracked by what's called a CVSS score. Okay. It's called a common vulnerability scoring system or something. Okay. So it has a score of 7.8, which is in the high level. Okay. And there are known affected configuration. It gives you a list of all the affected software products, Office 2010, Office Web, SharePoint, Word. So you can look at it and say, okay, do I run all these products in my company? Okay, if I run them, then are they in that version? Okay, 2016, or there might be even minor versions that are affected. So you got to make sure you deploy patches to your server that's running this software or your desktop that's running this software. Okay. Any questions so far? Okay. So the next concept I want to talk about is what's called a zero-day vulnerability. A zero-day vulnerability is a vulnerability, okay, that's been disclosed, but there is no patch yet. So this is what causes most panic for us. If there is a known vulnerability that's being exploited by hackers, but there is no patch issued by the vendor. So that's something where we got to be really careful. We got to look for methods outside of the patching system, close down registry keys or firewall ports, in order to make sure that attackers don't you make use of the vulnerability and get into my company. Okay. So this was one zero-day vulnerability. I think a patch was issued yesterday. Until yesterday, this was a 0 day. Because Microsoft knew about this, they knew it was under attack, but they did not have a patch for the whole of last week. This is 7 weeks is a big time, okay? When a vendor usually, even in the normal circumstances, when they issue a patch, hackers are able to reverse engineer the patch and actually find out what the security vulnerability is and develop a better exploit code. It takes just 1 day for the hackers to develop if you already have a patch and reverse engineer. But if you tell you have vulnerability and you don't have a patch, imagine the amount of excitement hackers will have. They'll be quickly able to analyze the operating system and the components that are vulnerable. In this case, if this vulnerability was vulnerability in Microsoft Word, okay, and Internet Explorer. So if an attacker was able to inject some kind of ActiveX code into your Word document and send you an attachment as in an email. So when you open the attachment, you'll get a Word pop-up, okay? And if you enable the ActiveX, it will open something in Internet Explorer and it will be able to download code into your desktop. So running code could be running malware, okay? So this was the panic of last week. And even when Microsoft releases their vulnerability bulletin, they also include the CVSS scores. So when I talked about CVSS scores, you will have several metrics that determine what the CVSS score is. So you will have what the attack vector is. You will look at the complexity of an attack. Okay, you'll have what privileges is required. You can be the normal user on a system, or you could be an elevated user. Okay, so I talked about CAA, right? How confidentiality is affected, how integrity is affected, how availability will be affected. So all of these metrics are used to calculate the entire CVSS score. When this score becomes high, what it means is there is a very high likelihood that a vulnerability will be exploited or a hack is available. Okay. So when it was a 0-day vulnerability, they said we don't have a patch. Microsoft doesn't have a patch, but you can do other workarounds in order to contain this vulnerability. So that's here where it says you can modify the registry, how to disable certain things. So then Microsoft released a patch for it. So we got to make sure all our servers have this patch. We have tools that can deploy patches for you on a large scale, like just called System Center Configuration Manager. That's a widely used tool in many organizations to deploy Microsoft updates. You can make sure you can schedule your updates. You can make sure your servers reboot at a time when there is not much activity, like Sunday night, or time where there is not many people working in the office. So you can schedule times and you can run update cycles in order to make sure your servers are up to date. Any questions? Can we do a quiz?
Yes, sir.
Okay. Okay. Launching the quiz. But let me give you the code in here. Okay, I sent you the code in chat. Go to slido.com 23401. You should be able to see the quiz. Okay. Give a couple of minutes for everybody to join. Slido.com 23401. Only 2 have joined. $18 people on the call. I think the rest of the people are sleeping. Come on, guys. Not tough questions. Four people have joined so far. We'll wait for 1 minute and we'll proceed. Anybody has any difficulties? Okay. Okay, let's start. For 6 members to communicate using asymmetric encryption, how many keys are needed? For 6 members to communicate using asymmetric encryption, how many keys are needed? Two more people? Okay. The correct answer is 12. So for asymmetric encryption, it's 2n. So 6 into 2, 12. Next question. A situation where a statement's author cannot successfully dispute its authorship or validity of an associated contract. What is this concept? Hashing, privacy, confidentiality, non-repudiation. Come on, quick, make a guess. One more person, I think. Correct answer is non-repudiation. So non-repudiation is a state where I cannot say I did not send a message. I did not cannot dispute that I did not do this. So that's what it is. Leadership leaderboard. Next question. Given the message digest of a hashing algorithm, one should be able to find the input. Is the statement true or false? Okay. I'm sorry. The correct answer is false because given just the message digest, you should not be able to find out the input. Given both the input and the output, you should be able to verify whether they match, but you should not just given the hash, you should not be able to go back and find out what the plain text is. It's like if I have the hash of a password, I should not be able to know what the password itself is. Okay? Can you answer this next question? Okay. Correct answer is Bob's public key. Okay. Leaderboard. Next question. One more. Just guess. Okay. So correct answer is B and C. Okay. So it either wasn't issued by a certificate authority, or sometimes you don't have the root certificate in your trusted root store. Okay. Which of the following RAID options offer the highest protection against disk failures? So rate 6 is the correct answer. That's because for every block distribution, you have 2 drives that for written for parity. Correct answer again, mandatory access control. Leaderboard. False. So tape is a method of offline storage. Correct answer is warm site. The first condition was to tolerate a few hours of downtime and a cost-effective solution at that. A cost-effective solution is warm site. Hot sites are expensive. Cold site cannot tolerate just few hours. The recovery time is typically few days or weeks. Leaderboard. Correct answer is encryption. So digital signature is used to prove your authenticity. It's used to prove that you are the person who sent it. It's used to prove non-repudiation, but just to maintain confidentiality, encryption is sufficient. Got it? So this leaderboard, congratulations to whoever has answered questions right. If you have any questions, please send me an email or you can send a message in your WhatsApp group. Thank you, everybody. I will see you in the next class.
Thank you, sir.